Hey, so I just wanted to show a few different of these linear patterns and how we can try to get the answer. There's obviously a lot of different ways to doing it. The first thing when you're looking at a pattern is try to identify what's changing each time. How is it growing? And the way that I see it, not the only way, but the way I see it is you started with three eggs on the bottom left corner, and then you're kind of adding another little L shape on top each time. And so step one had an L down there. Step two has two L's. Step three has three L's like that. And so if I look at step nine, I'm imagining there's just going to be nine L's in the problem. And how many eggs? Well, each L has three eggs in it. And so that would just be then 9 times 3, making 27. Other people might have chosen to just make it like a table or a list of numbers here, thinking that step one has 3, and then 6, and then 9, and 12, and just keep counting up by threes. That is a totally good strategy to get to step 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are two different ways of getting to the number of eggs in step 9. Let's take a look at something a little bit later on in the activity. That was the round one. I already discussed this sort of pattern in a different video. So let's look at the trees here. Step one, step two, step three. The way I see it is you've always got the three trees on the bottom, and then you're stacking another set of trees on top of that. But one downside of seeing it that way is that the number of stacks of two trees doesn't match up with the step number. So down here, step two has only one stack, and step three has has two stacks. So we could do that. But one other suggestion is let's look at these two trees also. So we're going to say this tree is our loner. So when I'm looking at it this way, now I see step one has a group of two trees. Step two has two groups of two trees. And step three has three groups of two trees each. And so if I look at step 23, what am I going to see? I'm going to see 23 groups that are two trees each, plus my one loner tree down in the bottom right corner. And so that gets you to 47. Maybe you don't like that method and you would have rather done this problem just with a list again. And so I'll show you how I would have done it with a list. So step one had three trees. Step two had five trees. Step three had seven trees. Step four had nine trees. And we could continue going as long as we want here. Nice thing about this method is it's not that hard to add two over and over again. As long as you just keep track of where you are, you can keep adding two. Downside of this pattern is, God, this is taking a while. I'm only on step 13 and I'm at 27, step 14, 29, step 15, 31, 33, 35, 37. I'm sure I'm losing some viewers as you're just watching me spell out all the numbers. I'm running out of space. Step 21, 43, 22, 45, step 23, 47. Great method for small numbers. Step 23 was a little bit annoying to write out all the things. And that's why we learn other methods, is because sometimes one method is more efficient or more reliable than other methods. Let's take a look at one more of these patterns here. This one here, this is asking us about step 43. I would not suggest writing out a table here, writing out a list of numbers, because that's going to take a while. And so I'll focus just on the other ways of doing it. So what I'm going to do is highlight the new blocks every time. So from step 1 to step 2, we have 1, 2, 3, 4 new blocks. 1, 2, 3, 4 new blocks. It's adding 4 blocks every time. In fact, I can even think of step 1 as having 4 blocks added on with one loner right there on the bottom left corner. So when I look at this, step 1 has one set of 4 blocks plus a loner. Step 2 has 2 sets of 4 blocks plus a loner. Step 3 has 3 sets of 4 blocks plus a loner. And so I know that step 43 is going to have 43 sets of 4 blocks plus 1. And so that gets me 4 times 40 is 160, plus 2 is 172, plus 1 gets me 173. All right. Thanks for watching. Please ask for more videos.